Thank you for the introduction. I would definitely like to thank Medtronic for funding our study. So we all know that BMD is a very important parameter, and low BMD, bone mineral density, is a risk factor which is associated with fractures, complication, and a poor outcome after surgery. And BMD is typically measured using DEXA. There are some alternatives like QCT and PQCT, but what we try to do in our project is to see if we can estimate BMD from MRI. I'm not talking about these bone-specific MRI techniques like the UT and ZT that requires some specific hardware and software which is expensive and not everybody has, but I'm talking more about these routine MRI like T1 and T2 weighted that we have all in our databases and we can use also retrospectively. And this, of course, would have the advantage that we have no radiation doses. So the idea was to use deep learning. Everybody's using deep learning today, and this is, I think, a good field of application for deep learning. And the idea is that we create a model that we can feed with the images, the T1 and T2 weighted MRIs, also with some information about the MRI hardware, the sequence, and so on. So all the parameters that are used to generate the image. And as ground truth, we take the BMD value that are measured with the DEXA. So we have the model that can predict the BMD using as ground truth the data from the DEXA. So we looked into our databases, and we were able to get data about 429 subjects which had MRI and DEXA within 6 months, so which is very important because we need to have images taken in a relatively short time frame. So majority of females, median age of 72 years, and we measured that 47% of the vertebrae had the T-scores lower than -1, which we defined as bone disorder, and 12% were osteoporotic. We tested several machine learning methods. I will not go into details because we don't have time now, but we tested a lot in order to be able to be sure that the method that we develop would be the best for in terms of performance. So here are some results. Here you can see a scatter plot. When we have on the x-axis the BMD value measured with the DEXA, and on the y, the one predicted by the model. And you can see that there is a correlation. So we have R of 0.45. There is definitely a correlation, statistically significant, but it's not that strong. And the mean absolute error of 0.16 is not that great. So it's something that works, but maybe it's not ready for clinical use. So we decided to change a little bit the strategy. And we decided to create a model that performs a classification. So we feed with the image, and the model tells us if the vertebra has a T-score lower than -1 or not. And you can see that in this case, it worked definitely better. We have an area under the curve of 0.82, which is definitely good. And here is the confusion matrix. And our test had a sensitivity of 0.71 and specificity of 0.77. So definitely quite better. We also did the same using osteoporosis as the classification value. So if the vertebra has a T-score lower than -2.5, the model still works quite well, you see, area of 0.8. But since we didn't have many data in our data set about osteoporotic vertebra, we can see that the sensitivity is relatively low. So that can also be improved. So coming to the conclusions, the classification task worked definitely better than the regression task. So the models in which we said that the bone is pathological or not worked definitely better than when we tried to predict the BMD. So this mean absolute error of 0.16 is quite larger than the measurement error that we have in the DEXA. So we might not be able to use that tool for clinical use, but if we try to use MRI as a screening tool to see if we have a bone disorder or osteoporosis, yes or no, this is definitely something that we can do already now. We definitely need more data, so if you have a data set, feel free to contact me. Let's keep in touch. And we wrote a paper which is now under review for European Spine Journal. And I would like to thank you for your attention, and again, Medtronic for supporting our test, our study.